Hi, in this video I am going to talk about working principle of pantograph when raise command is executed in the train. Right. Panto raise command is executed in the train, then how our entire circuitry works. So in this video I am going to talk about that. Right. So before starting with that, we need to understand about panto control unit. Now what is panto control unit? Panto control unit, it is a control unit which is responsible for raising and lowering of pantograph. And panto control unit has incoming pressure and it can vary from 5 bar to 10 bar. 5 bar is the minimum pressure, 10 bar is the maximum pressure. You must have been thinking there should be an optimum pressure which can raise the pantograph. Obviously there is an optimum pressure and that optimum pressure is of 7 bar, right? So optimum pressure 7 bar is can raise the pantograph easily, and if the pressure is more than 7 bar then also pantograph can be raised. But if the incoming pressure of panto control unit is less than 7 bar, then pantograph cannot be raised, right? So I have written about that. Raise command or execute only when 7 bar pressure is at the inlet of panto control unit. At the inlet of panto control unit, if the pressure value is of 7 bar, then only raise command will execute. If the pressure value is less than 7 bar, then raise command cannot be executed, right? Cannot be executed. Now once pressure reach to 7 bar at the incoming of panto control unit, then there is this valve named solenoid valve. We need to understand about this solenoid valve, which is very important component to make to raise the pantograph and to bring the pantograph at the lower position. Now once the pressure reach to 7 bar, then this solenoid valve is activated with the help of TCMS, right? Or can say this solenoid valve will get switched on with the help of the TCMS, right? Due to which pneumatic pressure will starts to flow from the circuitry, right? Now pneumatic pressure, as I said sometimes back, pneumatic pressure starts to flow from the circuitry. So circuitry means there would be different components about which I have already discussed, like pressure regulating valve, throttle raising valve, pressure gauge, right? So that is what I have written over here. Pneumatic pressure flows through pressure regulating valve, but what is the condition for that? Solenoid valve should get activated. It will get activated only when the incoming of panto control unit, incoming pressure of panto control unit is 7 bar or more than that, right? So pneumatic pressure flows through pressure regulating valve, which regulated incoming pressure to working pressure, or can say require pressure which can be monitored on the pressure gauge. Now you must have been thinking, what is working pressure? Now this working pressure is the pressure. See, we need to modify the incoming pressure of pantograph, incoming pressure of panto control unit. We need to modify the incoming pressure of panto control unit. Incoming pressure of panto control unit is of 7 bar, so we need to regulate it, right? We need to convert it into working pressure. Now you must have been thinking, what is working pressure? Working pressure is the pressure in order to maintain continuous static contact force, right? Static contact force. In simple word, I would say working pressure is the pressure which is responsible to maintain static contact force. Now you must have been thinking, what is static contact force? Now static contact force is the force which is required to keep the carbon strip in continuous contact with OHE. And for static contact force, working pressure is very responsible. So working pressure is the pressure which is responsible to maintain static contact force, and as I said sometimes back, static contact force keeps the carbon strip in continuous contact of OHE. So this pressure regulating valve which we have, it is this valve is converting incoming pressure into working pressure, right? And this working pressure can be monitored with the help of pressure gauge. As I said sometimes back, working pressure responsible for static contact force, and if I talk about magnitude of static contact force, it is of 70 Newton. Static contact force, static force, continuous contact, as I said sometimes back. Now raising speed of pantograph is controlled by throttle raising valve 1. Now see, pantograph is raising, so we need to control the speed of pantograph. See, in both the cases, when pantograph comes down and when pantograph raises, in both the cases we need to control the speed of pantograph to prevent pantograph against any major damage, or to prevent pantograph components against any major damage. So for that purpose we need to control the speed of pantograph. Now pneumatic air will go in air bellow, due to which air bellow will get filled up, due to which pantograph raises finally. See, here one thing that we need to understand, once the pantograph raised, once the pantograph comes in contact with OHE, then how we'll get to know about it? We'll get to know about it over the TCMS screen there is this one icon which shows pantograph has raised completely. It is in contact with OHE. So I'll get to know about it. We'll get to know about it with the help of this icon which is provided over our TCMS screen. So once I'll get the time in future, I will try to show you all of this thing practically, due to which each and everything will get clear, crystal clear, right? Now we are able to see the raised status of pantograph over this TCMS screen. So how it is happening? Again, it is happening with the help of the component which is located in panto control unit, and that the name of that component is pressure switch. With the help of the pressure switch, there is this electrical signal, and this electrical signal is responsible to show us the pantograph has come in contact with OHE, right? So I have written about this. Now pressure flows through insulated hose IH2 and enters in panto control unit and activates pressure switch 1. Pressure switch 1 will get activate, and this pressure switch 1 provides electrical signal. This pressure switch 1 provides electrical signal for pantograph raised status. Once this pressure switch will get activate, it will generate electrical signal, and due to this electrical signal we are able to see the raised status of pantograph over TCMS screen. So we can understand about all this thing with the help of this simple figure which I have drawn over here. Now this 7 bar pressure. This 7 bar pressure is the incoming pressure of panto control unit. So once this 7 bar pressure has reached over the panto control unit, then this solenoid valve 1, it will get activated with the help of TCMS, right? Now once this solenoid valve is activated, then the pneumatic pressure will start to flow from the pneumatic circuitry. Now pneumatic pressure will go in pressure regulating valve 1. It will convert incoming pressure into working pressure, which is responsible to maintain static contact force. Now pneumatic pressure will go in pressure gauge 1. With the help of this pressure gauge 1, we can see the magnitude of working pressure, and then pneumatic pressure will go in throttle raising valve 1. Now this throttle raising valve 1 will control the speed of raising speed of pantograph, and then pneumatic pressure will go in ABD, air bellow drive, due to which air bellow drive will get filled up. Once the air bellow drive is completely filled, then pantograph will come in contact with OHE. Now again the pneumatic pressure will flow from insulating hose IH2, and further this pneumatic pressure will go in pressure switch 1, due to which pressure switch 1 will get energized, due to which electrical signal will generate, and this electrical signal will go in TCMS, and TCMS will show us that pantograph has come in contact with OHE with the help of that icon. So same thing we can understand with the help of this circuitry. Okay, सेम चीज़ हम लोग ये सर्किटरी से समझ सकते हैं. तो यहाँ से अगर हम लोग देखें, सबसे पहला ये पेंटो कंट्रोल यूनिट में कितना बार प्रेशर आना चाहिए, ऑप्टिमम प्रेशर 7 बार. 7 बार का आएगा तो ऐसे केस में जो सोलोनाइड वाल्व 1 जो दिखाई दे रहा है ये क्या हो जाएगा, ये एनर्जाइज हो जाएगा. इट विल गेट एनर्जाइज. हाउ इट विल गेट एनर्जाइज? इट विल गेट एनर्जाइज विद द हेल्प ऑफ TCMS, and then that pneumatic pressure will go in PRV1 valve, pressure regulating valve. ये प्रेशर को क्या करेगा, इनकमिंग प्रेशर को रेगुलेट करेगा. इनकमिंग प्रेशर को किस में कन्वर्ट करेगा, वर्किंग प्रेशर में कन्वर्ट करेगा. फिर उसके बाद वो जो प्रेशर होगा कहाँ पर जाएगा, थ्रॉटल रेजिंग वाल्व में जाएगा, जो कि क्या करेगा, पेंटो की रेजिंग स्पीड को क्या करेगा, कंट्रोल करेगा. फिर उसके बाद वो जो प्रेशर होगा हमारा कहाँ पर जाएगा, एयर बेलो ड्राइव में जाएगा. एयर बेलो जो होगा वो क्या होगा, वो प्रेशर से फिल होगा. जब एयर बेलो पूरी तरीके से प्रेशर से फिल हो जाएगा तो ऐसे केस में हमारा जो पेंटोग्राफ होगा वो क्या होगा, रेज हो जाएगा. अभी जो प्रेशर है वो एयर बेलो ड्राइव में तो गया, साथ ही साथ यहाँ पर जंक्शन हमें दिखाई दे रहा है, जो प्रेशर है वो एयर बेलो ड्राइव में जाएगा, और यहाँ से होते हुए कहाँ पर जाएगा, इंसुलेटिंग हॉस 2 में जाएगा, IH2. यहाँ से कुछ इस तरीके से इंसुलेटिंग हॉस से हमारा न्यूमेटिक प्रेशर फ्लो होगा, कुछ इस तरीके से इंसुलेटिंग हॉस से. फिर उसके बाद वो जो न्यूमेटिक प्रेशर होगा वो कहाँ पर आएगा, हमारे प्रेशर स्विच 1 में आएगा. प्रेशर स्विच 1 में हमारे प्रेशर आ गया, वो प्रेशर न्यूमेटिक प्रेशर आ गया, जिसकी वजह से प्रेशर स्विच विल गेट एक्टिवेटेड. वंस दिस प्रेशर स्विच इज़ एक्टिवेटेड, इलेक्ट्रिकल सिग्नल जनरेट होगा, और ये इलेक्ट्रिकल सिग्नल की वजह से TCMS पर हमें पता चल जाएगा कि जो पेंटोग्राफ है वो क्या है, वो रेज कंडीशन में OHE के कांटेक्ट में आ गया है, राइट. अगर ये प्रेशर स्विच काम नहीं करेगा तो हमें पता ही नहीं चलेगा कि पेंटोग्राफ रेज हो गया. पेंटोग्राफ रेज तो हो जाएगा बट हमें पता नहीं चलेगा, क्योंकि प्रेशर स्विच इलेक्ट्रिकल सिग्नल ही जनरेट नहीं कर पाएगा, राइट. तो कुछ इस तरीके से हमारी पेंटो कंट्रोल सर्किटरी काम करती है जब हम लोग पेंटोग्राफ को रेज करते हैं. तो सो दैट्स इट फॉर दिस वीडियो. इन माय अपकमिंग वीडियो हम लोग ये डिस्कस करेंगे कि जब हमारा ADD ऑपरेट हो जाता है या फिर MED ऑपरेट हो जाता है तो हमारी सर्किटरी किस तरीके से काम करती है.